Hi, welcome to MA 207 course Differential Equations. We'll start our first topic, power series. Definition of power series. If you take a real values x naught, a naught, a1, a2, and so on, an, then the series, this series is known as power series. The coefficient, the constant is a naught, and coefficient of x minus x naught is a1, and so on up to infinity. This is called power series in x minus x naught with center at x naught. Okay. Okay, this power series, if we substitute a value of x, then it may be finite or it may be infinite. It is finite in this interval and it is infinite in this interval. So this region is known as the interval of convergence, and this R is called radius of convergence. How to find radius of convergence? We have two methods, and first method is root test, ratio test, and the limit L is equal to a n plus 1 by a n. The n plus 1 the coefficient of x minus x naught whole power n plus 1, and coefficient of x minus x naught whole power n. So the radius of convergence is 1 by L. Okay, we can find the radius of convergence using this formula. But we should be careful about this. A naught should not, an should not be 0. Okay. Before learning about the second method, we will study about lim sub function. If we take a series a1, a2, a3, so on up to an, then bk is defined as supremum of n greater than k an. If we take b1, then b1 is supremum of a1, a2, a3, so on up to an, and b2 is supremum of a2, a3, a4, so on an. We can see that b1 is always greater than b2, always greater than b3, and the lim sub of an is denoted by limit n tends to infinity bn. Okay, and the second test is root test. Okay, limits supremum of lim sub of an to the power 1 by n. It is L, it is denoted by L, and the radius of convergence is 1 by L. Okay, power series converges for all x belong to x naught minus r to x naught plus r. So this region is known as, this interval is known as interval of convergence. Okay, for example, we will take this series, we will find r. L is equal to, here we will use ratio test. N plus 1 whole factorial by n factorial, we will get infinity. So r is equal to 1 by infinity, it is 0. Okay, and we will second example, here we will get L is equal to 2, and so r is equal to 1 by 2. So therefore the interval of convergence is x naught minus r, 1 minus 1 by 2, so it is 1 by 2. So x naught plus r, it is 3 by 2. Okay, this is third example. Here we will get r is infinity, so it is a interval of convergence is minus infinity to infinity. Okay, next we have theorem for power series. So theorem has this following points. If we take this series is equal to f of x, then f of x is infinitely differentiable in the interval of convergence. And second point is we can differentiate it on both sides, and we will get this second point. Okay, and fx and kth derivative of fx have the same radius of convergence r. Okay, and the fourth point has how to find the nth coefficient of the series. We can use this formula. If we differentiate it on both sides, we will get this formula. Okay, similarly we can integrate on both sides, so we will get this formula. This is sixth point is unique representation of f as power series. For a given f, if we are able to denote by two power series, then the two power series must be same. So individual coefficients must be same. Okay, if a power series is equal to 0, then each coefficient is equal to 0. Okay, example, some important power series examples. E power x exponential, this is the power series. We can find coefficients by using the above formula. Okay, the second sin x, and 1 by 1 minus x, and the cos x, we can find cos x by derivating on both sides. Okay, we have another theorem. If there are two power series, then the linear combination of these two functions have the radius of convergence at least minimum of r1 and r2. Here r1 and r2 are radius of convergence of f and g. And by using above theorems, and we will try to solve an ODE. Okay, this is the ODE, and here center of this power series is 1, the solution of the ODE. So we will write this equation as 2 plus x minus 1. We need x minus 1, so we will all bring terms as x minus 1. Okay, we will express each term as a power series, individual power series. Here x minus 1 into y, second derivative of y. By using this formula, we will get this. And if we simplify, then here we in place of n minus n, here we kept n plus 1, so we will get this equation. Okay, each term we will take like this, and finally the whole equation is equal to a power series, and the coefficient is sum of the coefficients, and this should be equal to 0 because we are solving this equation is equal to 0, so each equation is 0, so we will take this as is equal to 0. We can find the bn by using an satisfying this recursive relation. Any an satisfying this relation will be the solution for this equation. Okay, thank you.